Okay, so let me write the title here for you. So, trigonometric equations. Yes, so what do we mean by trigonometric equation? Of course, equation means having an equality and unknown in the equation. But when you read this adjective trigonometric, it means that somehow it is related to sine, cosine, and tangent. Yes? So, in principle, there are three fundamental forms of trigonometric equations. One form is that you have sine of an unknown angle equals to some value k, and you are looking for x, and then you have cosine x equals to a given number k, or you have tangent of x equals to a given number k. But here we have some limitations for k, yes, because cosine cannot be bigger than 1, cannot be smaller than -1. Why is that? Do you remember? If we draw the unit circle, so what was sine? Sine was the sine was the y coordinate of the final point on this circle, and cosine was the x coordinate. Yes. So this circle is the unit circle. So here is 1, here is -1, here is -1, here is 1. So it is clear that the y coordinate cannot be larger than 1, cannot be smaller than -1. So this means that the sine of all the angles that you can imagine is at most 1, and at lowest 1 is -1. They cannot go beyond that. And the same for cosine. Cosine is the x coordinate. So for these two cases, k should lie somewhere between -1 and 1. But here, we don't have any limitations, so we can write from -infinity to +infinity, okay? But this is very, very simple. If you remember, I have talked about this more or less before. So in Math 1C, if I ask you to solve and find the x, the unknown angle, what do? You just go to your calculator and write sine inverse of k, and you get a number, yes? So that number is your unknown angle. But of course, in this case, we have more angles. In trigonometry, that was good for geometry, yes? But in trigonometry, we have negative angles, we have angles greater than, I don't know, 180, so 360 degrees, so we need to consider all of them. So we want to write a formula which will work for all of them. And then, even in Math 4, this formula is excluded from the formula sheet. So you need to imagine it every time so that automatically you send it to your memory, okay? Okay, so, but let you remember, I told you that example, and if you remember, I told you that I will give you a very precise, 100% precise ruler and 100% precise protractor, and I ask you, if you have those instruments in your hand, how do you calculate all these angles? So do you remember? For example, k is a number between -1 and 1. For example, let us assume that k is, I don't know, some number 0.7 or whatever. You mark it on the y-axis, and then you draw a horizontal line here. Then immediately see that you have two intersection points, yes? When you have two intersection points, this angle is one of those angles that you are looking for. If I ask you what is the sine of this angle, you would say it is the y coordinate of this point. But the y coordinate of this point is exactly k. So this is one of those angles that you are looking for. Yes? So what that angle is, that is exactly what calculator gives you. Okay? So you would say that x is sine inverse of k. But you know that if I start from here and go one full round and come back to the same point, even though my angle is now different from the previous angle, but because the final points are at the same point, the y coordinates are the same, so that bigger angle has the same value for sine, which is k again. Is that understandable? Yes? If it doesn't matter, if I go the other way around, in the negative direction, because do you remember this was positive direction, this was negative direction. If I start from here and go the other way around, one full circle, I will come back to the same point, even though that angle is now completely different from this angle, from magnitude point of view. But because the final points are at the same point, the y-coordinates are the same, and when the y-coordinates are the same, the signs are the same. Is that understandable? Yes or no? Yes. Okay, so what can I do? I can say that it doesn't matter how many full circles I go around, any multiple of 360 degrees can be added to this. It will give me another angle, but I will end up with the same endpoint, so the sign is the same. So if someone asks you what is this n, you would say this n is an integer, yes? 0 plus minus 1 plus minus 2. So how many angles I could find here by just this formula? Infinitely many. But I have written them compactly into the form of one single formula. This is one single formula, but it generates infinitely many angles for you, one corresponding to each choice of your n. But this is not the whole story, because I had two intersection points. This formula only takes care about this final endpoint. There is another final endpoint here. So what is that endpoint? So if I go here, again, if I ask you, can you give me another angle? You would say yes, because the starting point should be here again. Another angle is this angle. Okay? Okay, can you tell me what is the size of this angle? Use symmetry argument. I hope that you agree with me by using symmetry. The size of this angle that you see here, do you agree it is equal to the size of this angle that you see here? Yes, they are the same size. If I ask you what is the size of this angle, you would say it is sine inverse of k, whatever this number is. That would be this angle. But this angle is the same size of this angle, but I want this angle. So I need to write 180 minus this angle, which becomes this bigger angle, yes? So another possibility is to write x is equal to 180 minus sine inverse of k. Yes, do you agree with this one? This, if I ask you where this angle lies, you would say this angle lies somewhere with this endpoint. Yes? But then, with the same story, I can start from here and go one full round in this direction or the other direction, any multiple of full rounds. Yes? It doesn't matter. So I will add this again, n times 360 degrees. So I would say or between them. So this formula, I don't know, somehow for the next year at least, you need to send it to your memory. It is not included in the formula sheet. So you need to understand, you need to visualize this picture, or after a while, you will realize what is the correct formula. Is that understandable for everyone? So let me write this. This is what you need to understand. So if I give you a sign of a box, no matter, we don't know what is inside this box, and this is equal to k, where k is definitely should be somewhere between minus 1 and 1. If not, what do you say? If I ask you in an exam, solve this equation for me, what do you answer? You would say there are no solutions, because it is not possible to find x in such a way that sine of x becomes 2, because the maximum the value that sine can attain is at most 1. So if I give you this, for example, to solve, you immediately say that, okay, there is no solutions for this equation. Yes? But so if I want to ask you, and there are solutions, I have to respect this thing that k should be somewhere between minus 1 and 1. Then you immediately realize there are two groups of solutions. One group is the box, whatever inside the box is equal to sine inverse of that number k plus n times 360 degrees, or another possibility is that what is inside the box is 180. So this 180 you need to visualize or memorize after understanding, of course. So 180 minus sine inverse k, and then plus n times 360 degrees, and then n belongs to z. So this is something it's useful to remember. Of course, I will repeat this definitely in Math 4. The starting chapter in Math 4 is a very long chapter on trigonometry. So actually it is important to understand these things. Okay. Is that understandable? For example, let me give you a simple example. We want to solve this, okay? So sine of 3x is equal, for example, let me give one of those angles that I don't need calculator. So for example, let me write as 1/2. Okay, we want to solve this equation. So my unknown is x. So what is the box in this problem? Sine of something that I don't know is equal to 1/2. I'm supposed to find x. Yes? So 3x here is playing the role of that box. So what is the what comes next? You need to say that, okay, from here I can conclude there are two groups of solutions. One possibility is that the box is sine inverse of 1/2 plus n times 360 degrees. And the other possibility is that 3x is 180 minus sine inverse of 1/2 plus n times 360 degrees. Yes? So I have done nothing actually. I described the procedure to conclude this, but then I'm just using it. Is that understandable? Okay, but then either you should have this famous number in your memory, or you can use your calculator or the table of values. Sine inverse of 1/2 is 30 degrees. Okay, so this becomes 30 degrees. This was famous. Of course, if this is, for example, if I give you 1/3, I don't even know, so I have to use my calculator. You put this in the calculator, you get a number there, yes? So this is 30, so then what happens to this one now? Because this is 30, 180 minus 30 becomes 150. But it is not finished yet, because I am not looking for 3x. In an equation, I am looking for the unknown. The unknown is x here. So I want to find x. So what should I do? I need to divide everything by 3 to make x alone, yes? So if I do that, x becomes 10 degrees, and then I divide this, it becomes n times 120 degrees. So that is one possibility. Is this one solution? No. It is one group of solutions. There are infinitely many solutions in this. For example, if I put n equal to 0, then one angle is 10. That's correct. If I put n equal to 1, then it becomes 130. So another angle which will solve this equation for me is 130. If I put n equal to -1, for example, it becomes -120 plus 10, it becomes -110. Another angle that is a solution for this is -110. So I have infinitely many solutions grouped into one category, and I can express them all compactly with one single formula. And I do the same thing here. I want to find x, so I divide everything by 3. So x becomes 50 degrees plus n times 120 degrees. And it is important when you finish your solution, you tell the audience what do you mean by n. So by writing n belongs to z, or saying that n is an integer. So the angles that I can get from this are different from the angles here. For example, if I put 0, I get 50. If I put 1, I get 170. So I have infinitely many answers coming from this formula, infinitely many answers coming from that formula, yes? So I have these two. So this is the complete solution of this trigonometric equation. Is that understandable? Okay. Now, I want to actually make it a little bit more interesting. So what happens? Let me ask you one question. If someone tells you that sine of let me write alpha is equal to sine of beta, because you know that some functions are like this. If this combination is equal to the same combination with a different variable, then you can conclude these variables are the same. For example, if I say alpha to power 3 is equal to beta to power 3, what you can conclude about alpha and beta?
That they are equal.
They are equal. But for example, if I ask you the same question for alpha squared, what can you conclude here? You cannot definitely conclude that alpha is 100% equal to beta, because it might be that this is minus beta. So don't think that because the structures look similar, you can immediately conclude that these variables should be the same. Variables being the same is one option always, one possibility, but it might happen that there are more possibilities. Here, this was the only possibility. Here, of course, alpha equals to beta is one possibility again, because if alpha is beta, the structures are the same, so they are the same. But there are, and this means or, there is another possibility which is minus beta. Okay? Is that understandable? So now I want to ask you the same question here. The structure on the left is exactly equal to, similar to the structure on the right. Of course, one possibility is that alpha is equal to beta. But is this the only possibility? And if not, let us explore all possibilities together. So what can you tell about alpha and beta? So can you tell me what can I write in front of it? Yes?
It could be beta.
Beta. Or
it could be 180 minus beta.
yes? Is that understandable? Because if you say alpha is equal to beta, of course, if I have this situation, if alpha is this one, this is the endpoint. If beta is exactly this one, it is clear that the endpoint is the same, so the signs are the same. Is that understandable? Yes or no? Yes?
Yes.
Okay. But, as Dennis has said, if the other angle is pi 180 minus beta, it is this angle, the final point will be the mirror image of this one. And I hope that you agree, even though the x coordinates are different, but the y coordinates are still the same. Understandable? So this is why, if someone tells you that sine alpha is equal to sine beta, there are two possibilities. Either alpha is exactly equal to beta, or alpha is equal to 180 minus beta. But we have infinitely many more possibilities. What are those infinitely many more? This is not hard to guess, because I need to go round and come back to the same point, yes? So it means that I need to add n times 360 degrees here, n times 360 degrees here. That is also extremely important. So let me finalize it in this way. If someone tells me that sine of a box is equal to the sine of something else, the circle say, what can I immediately conclude? I can immediately conclude that what is inside the box is equal the circle, but might be they differ by a multiple of 360 degrees. Or, so this is, let me write or here. Or this is a 180 minus, minus the circle plus n times 360 degrees. So that is also important to understand. So sometimes you have the sign of an unknown equal to a number, but they are essentially the same. You don't need to memorize two types of formulas. You see they are very, very similar to here. Yes? Yes, but instead of this circle here, you have sine inverse of k. Okay, let me just give you one example here. We want to solve this equation. Let us consider this. Sine of 5x is equal to sine of 2x. We want to solve this equation. Okay, so you see, this is an equation because still x is missing. But here, if I compare this with that one, this is playing the role of the box. This can play the role of my circle here. Okay, so what happens? I have two possibilities. Either the box, which is 5x, is equal to the circle, which is 2x plus n times 360 degrees, or 5x is equal to 180 degrees minus 2x plus n times 360 degrees. Of course, I have to always emphasize that n it belongs to z. Okay? Is that understandable? I'm just copying that. After understanding what's going on, it's really important to understand this. Memorizing it should come automatically from my perspective, but if you don't understand it, it's really worthless here. Okay, so what can I do here? I am looking for x. So what is the next step? This is not done yet because I am looking for x. I haven't able to find x yet, so I will move 2x to the left. I can do it in my head. 5x minus 2x is 3x. So it becomes 3x equals to n times 120 degrees. And I am looking for x. So I have to divide by 3. X becomes, oh sorry, this is 360. And I divide by 3 to find x, so it becomes n times 120 degrees, yes? And then the same story here. But this time I need to move 2x to the right, it becomes positive, and this 5x becomes 7x equals to 180 plus n times 360 degrees. But I want to make x alone, so I have to divide by 7. I want to divide by 7, so x becomes, what was that? What is that? 180, yes. 180 divided by 7 plus n times 360 degrees divided by 7. If you want to keep it exact, this is the exact answer. If you want some approximations, you just divide by 7 and get your approximation values. So this is the exact value, yes? Okay, one more questions and then we are done. I want to ask you, of course, do you remember I told you that there are 3 types of equations? At least we can finalize the next one on Friday, but we don't probably need to study the tangent case. We will study it later. But let me just ask you one more question. If I ask you to solve this, sine of 2x equals to cosine of x. This is also a trigonometric equation, yes? I am looking for an angle so that all angles, not one angle, all angles, so that when I multiply that angle by 2 and take sine, it becomes exactly cosine of that angle. I want to discover if there is such an angle or not. Okay? So what should we do now? None of the things that I have talked about right now is directly applicable, because we just learned how to solve sine of an unknown equal to a number, which is not that type. We also learned how to understand the equality of 2 sines, which is not again this case, because one of them is sine, the other one is cosine. So do you know how to solve this problem now? This would be the last example today. I hope that I kept my promises this time. Yes? Any ideas? Yes?
I don't remember exactly, but there's a relation between cosine and sine. It's like 90.
Yeah, exactly. Thank you very much. Thank you. So that is a very important thing. So cosine is essentially the same as sine. You will later in Math 4, we will learn about the graph of those functions. The graph of the sine is this wavy function, and then the graph of the cosine is the same, but it starts a little bit something like this. So they have a different of shift of 90 degrees, more or less something like that. Okay, so this is good to remember. If 2 angles add to 90, then the sine of one of them is equal to the cosine of the other one, and vice versa. So this is the end of the story. Yeah? So I would write 2x, but instead of cosine x, I write something which is related to sine. So it becomes sine 90 degrees minus x. Yes? Because x plus 90 degree minus x. If I ask you what is this combination, you would say it is 90. So this is one angle, this is another angle. They are adding up to 90. So according to that rule that we learned, sine of one of them is equal to the cosine of the other one. So if I ask you what is the sine of this angle, you would say it is equal to the cosine of this angle. Is that understandable? So I am allowed to put this combination instead of this. These two things are equal. But what is the benefit? The benefit is that you can give the roll of the box to this guy, and you can give the roll of the circle to this one. And then immediately you can use 2 formulas, yes? So that was very good, thank you. So let us just do that and then finalize this session. So what we can do, we can say that 2x, either 2x is equal, do you remember what was that? It should be it should be the circle plus n times 360 degrees. So let me solve this one and then continue then for the next option. Here I'm looking for x, so I move it to the right. It becomes 3x is equal to 90 degrees plus n times 360 degrees. Then I divide by x. So x becomes 30 degrees plus n times 120 degrees. And you have to emphasize, in the exam you should be very careful about writing these things. So this is one possibility. But for example, if I put n equal to 0, x becomes 30. We can check. If I put 30 here, 2 times 30 is 60, and if you go back and look at your book, sine of 60 is square root of 3 over 2. And if I put 30 here, cosine of 30 is exactly that number. So that's correct. And then another scenario is that what is inside the box is equal to 180 minus the circle is this guy, plus again n times 360 degrees. Okay, so let us just do it. So this becomes 2x is equal to 180 minus 90 becomes 90, yes? Minus x is positive x. And then I have plus n times 360 degrees. And now I move x to the left, I am done, because 2x minus x is just simply x. I don't need to do anything extra. So it becomes 90 degrees plus n times 360 degrees. So you see, I have two groups of solutions. Infinitely many solutions with the main angle 30, infinitely many solutions with the main angle 90 degrees. Yes? Is that understandable? Okay. So this would be the end of this lesson today. Okay, thank you.